Swayam Prabha. Digital India. Educated India.
Namaste. We move forward with our revision, and today we will start with module 5, forest surveying. So, we saw that survey is the act of making measurement of the relative position of natural and man-made features on the earth's surface and presentation of this information either graphically or numerically. So, you take measurements and you also have to present this data either graphically or numerically. There are 3 stages of surveying: taking a general view or the reconnaissance survey, observation and measurement, and presentation of data. Then we saw that there are 2 types of surveying: plane surveying, when you take the surface of the earth to be a flat plane, and this approximation is generally true when you are surveying smaller areas less than 250 square kilometers in size. If you have larger areas, then you have to take care of the curvature of the earth, the true shape of the earth, which is a geoid, and in this case it is known as a geodetic surveying. Now, surveying was generally done with classical tools such as chain and tape survey. Now, in the case of chain and tape survey, you only take linear measurements, there are no angular measurements that are involved. Secondly, you have compass survey, in which case you take angular measurements using compass and linear measurement using a chain or a tape. Then you have plane table surveys, in which you take measurements and these are converted into drawings on a plane table, and typically you only need to have 2 points, you know the distance between both of these points, they are in the straight line, and for the rest of the points you only take the angular measurements, and just by taking angular measurements you are able to plot them out on the sheet, where you have to measure the horizontal and the vertical angles both. Now, measurements can be direct measurements made using some measuring device or instrument, or indirect measurements that are made using an observable proportion or ratio, such as the stick and shadow method. Then we defined error as the difference between a measured value and the true value, and the properties are that there is no measurement that is exact, all the measurements have some error, and because of this error you can never know the true value of anything. Now, if you do not know the true value, you also cannot know the exact error, because your definition of error involves this true value, and you can never measure the true value, because even if you are trying to measure the true value, there will be certain errors that will be involved. So, we try to take measurements in a way that the relative between the measurements cancel out the errors. Next, we have the sources of errors. There are 3 main sources: natural, due to variability in natural conditions such as temperature, or you have instrumental errors if your instrument was not built properly or over time it has become worn out, or there are personal errors when you are doing an error in the measurement because you are not following the correct procedure. Then we looked at the difference between precision and accuracy. Precision is how close the measured values are to each other, and accuracy is how close the measured values are to the correct value, and we represented them in the form of these shots on a target board. And here we said that these measurements are precise and accurate, these are precise but not accurate, these on an average are accurate but not precise, and these are neither precise nor accurate. Then we defined bias as the difference between the mean of the measured values and the reference value, and if the reference value is the true value, then bias is the error in measurement. So, this is the bias. The shooter wanted to shoot at the bull's eye, so the measurements are precise, but these are not at the bull's eye. So, they are at a distance, and this difference is the bias, and bias is can be removed by calibrating the instrument or the method of measurement. Next, we looked at basics of sampling. So, there is a difference between census and sampling. In the case of a census, you take or you measure everything. In the case of sampling, you measure only a small portion of the whole population. The objective of sampling is to secure a sample which will represent the population and reproduce the important characteristics of the population under study as closely as possible. Then population is defined as the aggregate of units from which a sample is chosen, and sampling unit is defined as the subdivision of the population for the purpose of sampling. And these can be administrative units or natural units such as topographical sections or subcompartments, or even artificial units like strips or plots and so on. Now, a list of all the sampling units is called as the frame, and out of this frame you select a few of the samples. So, one or more sampling units that are selected from a population according to some specified procedure will constitute a sample. And we also have the sampling intensity, which is the ratio of the number of units in the sample to the number of units in the population. So, if you have more number of units in your sample, then your sampling intensity is more. So, say you have 100 individuals, and if you are measuring 10 individuals, then you have a sampling intensity of 10%. If you are measuring 90 individuals, then you have a sampling intensity of 90%. Now, we looked at the kinds of plots. They can be circular, rectangular, strips, or they can even be topographical units as are used in hills. Now, depending on the procedure, we define simple random sampling, in which case the each possible combination of sampling units out of the population has the same chance of being selected, such as a lottery. Then there is systematic sampling, which uses a formula of selecting every kth unit starting with a number that is chosen at random. Next, we have stratified sampling, in which case you divide the heterogeneous population into subpopulations known as strata, each of which is internally homogeneous, in which case a precise estimate of any stratum mean can be obtained. Next, we have multi-stage sampling, in which you first select the large size units, and then you choose a specified number of subunits from these selected large units. And then you have PPS sampling, or the probability proportional to size sampling, in which case when the units vary in their size and the variable under study is directly related to the size of the unit, such as the mass or the biomass, the probabilities may be assigned that are proportional to the size of the unit. So, in a PPS sampling, the largest sized individuals are better represented. Next, we looked at photogrammetry. Photogrammetry is the science and technology of obtaining spatial measurements and other geometrically reliable derived products from photographs. So, you are obtaining spatial measurements and other geometrically reliable derived products. So, in this case, we are doing some sort of a survey that is being done using photographs, and this survey is being done in such a manner that you are able to measure things out. It is a form of remote sensing, defined as the acquisition of information about an object or phenomenon without making a physical contact with the object. Now, photogrammetry is based on the principle that triangulation permits depth perception. So, you have for instance, you have two eyes, and with both these eyes you are able to perceive the depth of different objects, depending on what is the angle that your eyes are subtending, or what is the parallax error that you are seeing. So, in this method you take photographs from at least two different locations, develop lines of sight from each camera to the points on the object, and then mathematically intersect these lines of sight to get the 3D coordinates of the point of interest. So, this is the principle. You are taking different photographs in a two-dimensional manner, then putting them through the mathematical computations of photogrammetry to get a 3D representation of what the actual object is. So, the applications can be interpretive to interpret the situation, or metric to measure something. Then we looked at the use of drones. So, this is a satellite image, this is the drone image. So, we can use it for interpretations, such as we saw that this building was not there in the satellite image, but it is there in the drone image. So, it was built after the satellite image was taken and before the drone image was taken. So, it can be used for such interpretations. You can see a difference in the land use. So, earlier these areas were plain like this, now these areas are dotted, which means that there is a plantation that has come up in this area. Next, we saw that in the case of drones, you can fly them at a lower height, in which case you will start seeing the plants themselves. So, these green spots are the plants, and when you are seeing these plants, you can even use this data for finding out the viability of different plants. Then we looked at how we can perform these computations in an automatic manner. So, there we started with this image of the pits that are dug and the soil that is there along with the pits, we converted them into a black and white image, a binary image, and with this binary image the computer was able to tell us what is the number of pits that are dug, what are the sizes of different pits, what is the average size of each pit, and so on. In the case of photogrammetry, we typically use 3 different kinds of platforms. They can be ground borne platforms, in which case you are using cameras on the ground and the camera is horizontal, or you can make use of space borne platforms, in which case you are using satellite data, and in this case the camera is vertical. The third option is that you can make use of airborne platforms, in which case you use an aircraft or a drone, and in this case the camera may be at any angle. Now, we defined spatial, temporal, spectral and radiometric resolution. Spatial resolution is the ground size of a pixel in the image, essentially how many megapixels do you have in your camera. Temporal resolution is how frequently are you taking pictures or the frequency of flyovers. Spectral resolution is whether you are taking a black and white image or you are taking a colored image in 3 different bands or even more number of bands. So, it is the number of frequency bands that are recorded. It is just 1 band in the case of a black and white image, 3 bands in the case of an RGB image, and even more number of bands when you are also taking into account the infrared bands, the UV bands and so on. Next, you have the radiometric resolution, which is the number of different intensities of radiation that the sensor is capable of distinguishing. So, essentially here you are talking about what is the amount of information that is there in each band, how many bits of information can be distinguished. Next, we had a look at the parameters that define a good photograph. So, you have to look at the field of view, which depends on the focal length and the angle at that the camera is subtending to the object. Next is the focus, and we said that the depth of field depends on the f number. So, if the f number is large, such as say f11 or f20, in that case the aperture is very small in size and the depth of field is very large. On the other hand, if the f number is small, say f2, in that case you have a large sized aperture, and in this case you have a very small depth of field. Here we defined far range photography or far range photogrammetry, where the focus is at infinity, and close range photogrammetry, where the focus is at a finite distance. And we saw that exposure depends on shutter speed, ISO and the f number. Next, we talked about the orientation of the camera axis. You have true vertical, near vertical and oblique axis or oblique orientation. In the case of true vertical, it is a hypothetical thing. The best you can get is a near vertical, and in the case of oblique orientation, you have high oblique where the horizon is visible and a low oblique where the horizon is not visible. Then we looked at differences between vertical and oblique photographs. In the case of vertical photograph, it is a more uniform scale, measurements are easier. In the case of oblique, there are differences as you move across the photograph and so on. Now, in the case of airborne platforms, you need to ensure that there is a sufficient amount of overlap between different images, and there are certain corrections that need to be done. If the altitude varies during the flight, the scale will vary. So, you try to fly your aircraft at the same altitude, and also you record the altitude, so that if there are any changes to be made according to the altitude in the final image, that can be made. The tilt, if it varies during the flight, then the scale will vary with the camera tilt across the photograph. Then there are several distortions, the lens distortion, atmospheric distortion and edge distortion, and there is also a parallax shift with the altitude. Now, in the case of measurements, you try to take a good overlap, so that you are able to have stereo viewing of these different locations, and you can make use of parallax shift to get an idea of the altitude. Now, when you are using photographs to take measurements, it is good to use a metric camera, which is a stable, which has stable and precisely known internal geometries, low lens distortions, constant focal length of the lens. The image coordinate system is defined by 4 fiducial marks mounted on the camera's frame, and the aerial metric cameras built into the airplanes look straight downwards. If you want to take stereo measurements, you take stereometric cameras, in which case you have 2 metric cameras that are mounted at the ends of a precisely measured bar, and both of these have the same geometric properties. Now, applications of aerial photography to make large scale plans, cadastral maps, land use maps, topography, hydrography, and exploration and reconnaissance. Products, you can get a digital elevation model, orthophotos, you can get thematic GIS data and other derived products and maps. And then we looked at how we make use of the of photogrammetric principles to get a 3D view, and here we saw a 3D view of the Madhubalai Tiger Reserve, and we are also getting certain thematic information such as where the streams are located. Next we had a demonstration of this 3D video. Then we saw how we can use photogrammetry to discern water in a region, taking the example of the Bhoj lake or the upper lake in Bhopal. And in the next lecture we had a look at LIDAR, which is light detection and ranging. It is the word is made from a combination of laser and radar, where radar is radio detection and ranging. So in this case, this is an active remote sensing technique because you require energy to illuminate the object using the lasers. It is an airborne laser scanning system or an ALS system developed in 1960 by Hughes Aircraft. We use laser because it is a monochromatic beam, it is a directional beam, it retains its strength over long distances. The concept is that you get position of the aircraft using differential GPS, in which case you have two stations, the ground station and also one station which is located in the aircraft. So you use differential GPS and inertial measurement unit to get an idea of the acceleration and the orientation of the aircraft. And when you shine a laser beam, it goes interacts with the surface of the object and then it comes back. So how much time does it take for the laser beam to go from the aircraft and back is then calculated, and the distance to the surface is given by c into t by 2, where t is the time it takes for the laser beam to come back. And by keeping track of angles, we can get a 3D scan. The components are laser, there is scanner and optics, photodetector and receiver electronics, and positional and navigational systems. We saw that it works in two modes, LP mode, which is the last pulse mode, where the last return pulses are received, and the FP mode, which is the first pulse mode, where the first return pulses are received. And you can make use of LIDAR to get a DEM image, which is a digital elevation model, which represents the elevation of the tallest surfaces at a point, and a DTM model, which is a digital terrain model representing the elevation of the ground. And you can subtract DTM from DEM to get a DHCM, which is a digital canopy height model. And so now in the case of scanning mechanisms, there are three typical scanning mechanisms that are used: an oscillating mirror, which gives you a sawtooth pattern, a rotating polygon, which gives you parallel lines, and a nutating mirror, which gives you elliptical shaped ground patterns. Now you can make use of a LIDAR in two families. You can make use of waveforms, or you can make use of information in a discrete pattern. When talking about the wavelengths, you have the topographic LIDAR, in which case near infrared light laser is used to map the land, or you can make use of bathymetric radar, in which case a water penetrating green light is used to measure the sea floor and the riverbed elevations. In forestry, you can use LIDAR to get an idea of the DEM, canopy structure, even the different cross sections of a tree, leaf area density, digital canopy height. You can measure carbon stalks. You can use a horizontal LIDAR and get a better idea of the carbon stalks, or you can even study the plant growth and shape change as the plant grows, or you can use it to understand how your stand is behaving. Do you have only young crops, do you have mature crops, do you have old crop, or do you have a mix? So you can get a very good and a very fast idea in a very economical way. Next we looked at forest protection. So here we started with the kinds of threats. So you have natural threats and you have man-made threats. Natural threats are frost damage, wind throw, insects and pests, diseases, damage by animals, invasive species, climate change, forest fires. And man-made threats include illegal felling, illegal mining, illegal grazing, encroachment, degradation and pollution, poaching, invasive species, climate change and forest fires. And we can emphasize that in the case of invasive species, climate change and forest fires, you can have both natural as well as man-made causes. Then we saw the impact of humans on the environment of forest is given by this equation: I is equal to P into A into T, where I is the impact, P is the population pressure, A is the affluence or the per capita need for resources, and T is the technology or the ability to extract these resources. So, if you have a large size population, everybody needs more resources and you have the technology to extract these resources, in that case the impact will be very high. Next, we saw how to estimate the rate of species loss using the island biogeography model, in which case S, or the species richness, is given by C, a constant of proportionality, times A, or the size of the island, to the power of Z, which is again another constant, which and this constant varies in different locations, and the values are typically between 0.15 and 0.35. And in this case we saw that even if an area decreases by 90%, you still have roughly 50% of the species richness that remains in that area. So, there is ample scope for hope, but you cannot be extremely hopeful, because then we calculated the rate of species loss and we saw that in the case of tropical forests, we are losing as many as 27,000 species every year in a very conservative estimate. Then we saw that all species are not equally susceptible to extinction. It depends on the rarity of species. If a species is rarer, then it has a greater chance to be extinct. And some species are rarer because they are restricted to an uncommon habitat, they have a limited geographical range, or they have low population densities. Then we looked at this acronym HIPPO, which is a good mnemonic to remember the factors that are leading species towards extinction. So, H is habitat loss, I is invasive species, P is pollution, the other P is human overpopulation, and O is over harvesting of resources such as overfishing or over extraction of timber. Now, why does a population become extinct? You have two different kinds of factors. You have deterministic factors that act at large population sizes, such as birth rates and death rates, and you have stochastic factors that act at small population sizes. So, deterministic factors include birth rate, death rate, and the structure of the population, whether most of the individuals are young, most of the individuals are old, or most of the individuals are of a mature stage. In the case of stochastic factors, you have demographic stochasticity, which is the probabilities in reproduction, litter size, sex determination, and death. So, it is just possible that most of the animals are having a very small litter size, just one progeny, and if that happens, then the population is more pushed towards extinction if the population size already is very small, or if all the progeny turn out to be males, or all of them turn out to be females. Then we have environmental variation and fluctuations, catastrophes such as forest fires and diseases, genetic processes, deterministic processes such as density dependent mortality, and migration among populations, and all of these are the stochastic factors. Now, next we saw that the sensitivity of the species to human impacts is dependent upon the adaptability, resilience of the species, the amount of attention that humans are giving to the species. So, charismatic species like tigers are more sensitive. Ecological overlap between humans and the species, and the home range requirements of the species, in which case the species that require a larger home range size are more susceptible towards extinction, because if their home range reduces, then they are unable to cope with it. So, there is a need for protection. In the next lecture, we started with forest fires. This is an example of a forest fire, and a forest fire is defined as a generally uncontrolled fire in an area of combustible vegetation in the forest. And we saw that a forest fire occurs when you have all the three vertices of the fire triangle. So, you need to have fuel, you need to have air, and you need to have heat. When all three of these are there together, then you have the forest fire. There are certain natural causes of forest fire, such as lightning, volcanic eruptions, rubbing of dry bamboo, friction of rolling stones, but most of the causes these days are anthropogenic causes, such as shifting cultivation, flushing the growth of tendu leaves by exposing the plants to fire, or burning an area to have a good growth of grasses, rivalry with the forest department, personal rivalry between two people, encroachment, clearing for road to conceal illicit filling, to divert the attention of forest officials for hunting, and certain customary causes, such as in the case of certain tribal societies. Now, these are all deliberate anthropogenic causes. You also have certain accidental anthropogenic causes, such as burning of crop residues. There is a chance that some of these burning fragments because of the wind they move to the forest areas and they start a forest fire. Or driving of wild animals, throwing of lighted BD, campfires, prescribed burning that has gone uncontrolled, charcoal making in the forest, heating of coal tar for road construction, sparks from transformers, sparks from vehicles, and all of these are the accidental anthropogenic causes. Then we have 5 different kinds of forest fire. You can have a ground fire, which is fed by subterranean roots and buried organic matter, difficult to detect and put out, and it is very easily detected if you have a snag tree, because you will suddenly find a tree that has started to burn. Then you have surface fire, which is fed by organic matter on the forest floor. You have ladder fire, which consumes the material between the forest floor and the canopy, common in areas with invasive climbers. You have crown fire or the canopy fire, which consumes material at the canopy level, and you have the firestorm, in which case you have an extremely large fire that is creating and sustaining its own wind system. Now, the impacts of forest fire, there are changes in soil development, nutrient circulation, increased soil erosion, silting of reservoirs, altered rates of evaporation and transpiration, loss of species, loss of biodiversity, curtailment of natural succession and regeneration, changes in species distribution and stand composition, altered pattern of resource availability for animals, especially shelter and food, large scale release of carbon dioxide, loss of life and property, loss of livelihoods. And so, it is important to manage the forest fires, and this management is done by taking the steps for prevention, fire monitoring and reporting, firefighting, rehabilitation of forests, and community mobilization. Now, we looked at a study in managing forest fires. So, you need to break the fire triangle, and because in the in a tropical forest or in a deciduous forest you have a very good ground cover, and in the summer seasons it is all full of dry leaves that the trees have shed. So, in that case we go for the construction of fire lines. Now, a fire line works on the principle that if this section is burning and you have these areas that do not have any fuel, then the fire will be unable to cross into the second section of the forest. So, what is the principle? You have 2 forest floors. So, this is a simulation, and the fire is burning, it is coming towards the front is coming towards the fire line, and because it does not get any more fuel, so it gets burnt. The on-site construction in the months of October and November, typically the ground cover is removed in these areas, the plants are left to dry out, and once they have dried they are burnt. And on a larger scale, if you have so here you are seeing a wider fire line, and so the staff will make use of rakes to bring all the dry leaves towards the center. Then they will use a stick, convert it into a torch, and this torch is used to burn the accumulated leaves, and this burning will be done. So, you burn it from this side so that it enters here, and you burn from this side so that a fire front moves towards the center, and when both of these fire fronts meet, then the fire gets extinguished, and this is done on a large scale. But there are certain issues. There is the issue of bleeding, in which case you were constructing a fire line, but then when you were burning it, it burned the whole forest. Then you have the issue of infiltration, in which case once the fire line has been made, the leaves are coming and on top of these fire lines, because the trees are still shedding the leaves. So, if you have the leaves here, then you still have fuel in the fire line. Next, you have the issue of repopulation, in which case once you have constructed the fire line, after a while new flush of grasses can come in, and when these grasses die or when they dry up, in that case you will again have fuel in the fire line, which then defeats the purpose. Next, you have mosaicing, in which case certain portions are left out, they are not burnt, and here again you have a discontinuity in the fire line. Now, if you have these kinds of discontinuities, then that can hamper the working of your fire line. So, a simulation is shown here. So, you have 2 forest floors, you have a fire line, but in between you have the leaves, and once that happens, the leaves make a channel between both the forest floors, and the whole forest burns. So, then we constructed fire breakers to prevent bleeding. There were 2 aims. There should not be a habitat fragmentation. So, you cannot have very tall walls, and you do not want to add anything to the system. So, it has to be made from natural materials that are locally available. So, mud fire breakers were made, and they were in 2 shapes, and both of them work. So, you have a fire that is coming from the left side and reaches the fire breakers because it is made of earth, which is a non-combustible material. So, it stops there. Now, if you try to simulate the leaf fall, if it comes on top of this cuboidal fire breaker, then it will burn. The flames will be able to reach the top, and after a while, if there is a wind movement, then there is a possibility that the fire will reach to the second side and it will burn the second side as well. But in the case of a prismatic fire breaker, because flames can only go up, they cannot go down. So, the second side is much more protected. And so, we recommended that in the case of a fire line, on both the sides we should be making the fire breakers. Now, we looked at the elements of a fire management plan. It has to look at the forest areas, the fuel types, what are the responsible organizations that you can look forward to. You need to have a fire prevention plan with fuel hazard reduction, a fire danger measuring system, detection plan, reporting plan. You need to have alarm systems in communications. There has to be a plan for fire suppression, personnel management, equipment and tools, supplies, safety measures, and maps and records. And we looked at simplifier, which is another method in which we are getting a near real time reporting of the forest fires. And then we also looked at the working of fire maps, which help you to discern which locations are having a greater possibility of fire and which locations have a lesser possibility of having a forest fire. Next, we looked at forest law. So, we began with the Indian Forest Act 1927, and we saw that in the case of the Indian Forest Act, here you have defined the forest offence, you have the forest produce, timber, tree, and the government has the power to reserve the forest. And in the case of reservation of forest, the government needs to appoint a forest settlement officer. The forest settlement officer has certain powers, and so no right can be acquired over a reserve forest except as herein provided. The government has the power to stop ways and water courses, and this power can be given to the forest officers by the government. Then there are certain acts that are prohibited in such forests. So, these laws are now providing powers to the forest officers to protect the forests. So, what are the things that are prohibited? Making a fresh clearing, setting fire, kindling any fire, leaving any fire burning, or trespassing, pasturing of cattle, damage by negligence, damage to trees, quarrying, collection, removal, breaking up or clearing of land for any purpose, hunting, shooting, fishing, poisoning water, setting traps or snares, killing or catching elephants, and so on. So, all these things are prohibited in a reserve forest. Next, we have village forests, and the state government may make rules for regulating the management of village forests. Then we have protected forests, and even in the case of protected forests, the government can declare any trees or classes of trees to be reserved. And then you have options of closing certain portions of the forest. So, when you are closing it, then it is closed for grazing. Then you have a prohibition of quarrying, burning of lime, charcoal, collection and manufacturing, removal of forest produce, breaking up or clearing of land for cultivation, building, herding cattle, or for any other purpose. So, this was about the protected forest. Then penalties have been set in, and in the case of the Indian Forest Act, the imprisonment is for a term which may extend to 6 months, or with a fine which may extend to 500 rupees, or both. Then we have the protection of forest for special purpose. This can be taken up by the government, or in certain cases the protection of forest can be done even at the request of the owners of the forest. Then the government can impose duty, the government can decide what are or prescribe the routes from which the forest produce can be moved. We can have prohibition of import and export and moving of timber and other produce without a pass. We can set up nakas and chowkis where we can look at these forest produce, and we can stop people. We can there is a system of reporting, examination, and marking of timber and other forest produce in transit, in which cases you issue the transit passes. Then you have provision for the establishment and regulation of depots and so on. You can the government can control where the sockets will be set up or not set up, and you have the converting, cutting, burning, concealing, marking of timber. All of these can be controlled. There is also a provision of use of property marks, which we generally refer to as hammers, and then you have the powers of the central government to the movement of timber across custom frontiers, penalty for the breach of rules. Then drift and stranded timber are also government property. So, you cannot say that you found out a piece of timber which was just lying around, and then government has the power to make rules and prescribe penalties. There can be a seizure. So, if somebody is doing a forest offence, then the forest produce together with the tools, equipments, carts, animals, whatever is being used for doing this forest offence, they can be seized and they can even be confiscated. When something is confiscated, it becomes a government property. Then we have the power to arrest without warrant. So, everything is cognizable, and power to prevent commission of offence, power to try offences summarily, power to compound the offences. There is a presumption that all the forest produce belongs to the government. Cattle Trespass Act still applies, and the government may invest forest officers with certain powers, such as power to enter upon any land, survey any land, demarcate any land, make a map of any land, powers of a civil code, to compel the attendance of witnesses, production of documents and material objects, power to issue a search warrant under CRPC, power to hold an inquiry, to receive and record evidence, and all such evidence shall be admissible in a subsequent trial before a magistrate, provided that it has been taken in the presence of the accused person. And the forest officers are deemed to be public servants, and the government also has the power to make additional rules. So, this is about the Indian Forest Act. Next, in the Wildlife Protection Act, we saw that hunting is defined in a very large terms. So, killing of animals, poisoning of wild animal or captive animal, or every attempt to do so, capturing, coercing, snaring, trapping, driving, baiting of any wild or captive animal, and every attempt to do so, injuring, destroying or taking any part of the body of such animal, or in the case of wild birds or reptiles, damaging the eggs of such birds or reptiles, or disturbing the eggs or nests of such birds or reptiles. All of these are hunting. Now, protected area means national park, sanctuary, conservation reserve, or a community reserve. So, these are the 4 different kinds of protected areas that the Wildlife Protection Act sets up. Then we have weapon, which includes ammunition, bows, arrows, explosives, firearms, hooks, knives, nets, poison, snare, trap, or any equipment or apparatus capable of anesthetizing, decoying, destroying, injuring, or killing an animal. So, for instance, if somebody goes into a forest with a darting gun and uses that darting gun to immobilize an animal and to capture that animal. So, in this case, this darting gun becomes a weapon, because it is something that is capable of anesthetizing the animal, and the act of immobilizing or anesthetizing the animal, or even the attempt, is hunting as per the Wildlife Protection Act. Then we have prohibition of hunting under section 9. So, in this case we have a prohibition of hunting, there is not a ban on hunting. So, basically you cannot do hunting unless otherwise permitted as per section 11 or section 12. Next, we looked at a prohibition of picking, uprooting, etc. of specified plants. So, Wildlife Protection Act even protects the plants. Dealing in plants prohibited without license, declaration of stock, possession, purchase plants to be government property. So, all these things are being regulated by the Wildlife Protection Act. Then you have declaration of the sanctuary, and once a sanctuary is declared, there are certain restrictions. So, no person other than a public servant on duty, a person who has been permitted by the wildlife warden or the authorized officer to reside within the limits of the sanctuary, a person who has any right over immovable property within the limits of the sanctuary, a person passing through the sanctuary along a public highway, and the dependents shall enter or reside except under and in accordance with the conditions of the permit. And every person shall, so long as he resides in the sanctuary, so every person is bound to do certain things, such as prevention of commission of an offence. If any such offence has been done, to help in discovering and arresting the offender, to report the death of wild animals, and so on. Next, certain permits can be granted. So, even regulation, even the granting of permits is regulated by this act. Destruction etc. in a sanctuary is prohibited without a permit. Causing of fire prohibited. Prohibition of entry into sanctuary with a weapon. Ban on use of injurious substances. Immunization of livestock. Registration of persons in possession of arms. Power to remove encroachment. Then in the case of a national park, you again have a number of regulations about grazing, about other protection measures, declaration and management of a conservation reserve. Now, in this case, the management is done by a conservation reserve management committee. In the case of a community reserve, it is done by a community reserve management committee. Then we also had a look at the Forest Conservation Act, which section 2 says restriction on de-reservation of forest or use of forest land for non-forest purpose. So, here also it says that there is a restriction, there is not a ban. If you want to use it for a non-forest purpose, if you want to deforest certain portion, it has to be done under certain provisions. And the non-forest purpose has been defined as breaking up of or clearing of any forest land or portion for the cultivation of tea, coffee, spices, rubber, palm, oil bearing plants, horticultural crops or medicinal plants, any purpose other than reforestation, but it does not include any work relating to or ancillary to conservation, development and management of forest and wildlife. Then this act also prescribes the penalty for contravention, and the penalty is a simple imprisonment for a period up to 15 days. So, that was about forest law. Now, in the next module, that is silvicultural management part 1, we looked at regeneration. So, regeneration is the act of renewing the tree cover by establishing young trees naturally or artificially, and generally this is done promptly after the previous stand of forest has been removed. There are 3 ways of regeneration: natural regeneration, artificial regeneration and assisted natural regeneration. So, we refer to these as NR, AR and ANR. Now, in the case of artificial regeneration, you can have artificial regeneration by direct sowing or by planting of seedlings. Now, natural regeneration is defined as re-establishment of a forest stand by natural means, that is by natural seeding or vegetative regeneration. It relies on older trees that are left on the land to provide seed to regenerate the site, and it can be employed only if the site has not yet been harvested. So, the steps are selecting the seed trees, logging without damaging the seed trees and allowing time for the site to regenerate naturally. It depends on seed production, seed dispersal, seed germination and establishment of the new crop. Now, seed production depends on seed year, age of the tree, size of the crown, climate and external factors. Seed dispersal can be done by wind, water, gravity, birds, animals. Germination depends on moisture, temperature, seed viability, permeability of seed coat and so on. And establishment refers to the development of a new crop to a stage where the young regeneration is considered safe from normal adverse influences like frost, drought or weeds. So, once your new crop has become established, it means that now you can be rest assured that any normal adverse influences will not have a major impact on the young crop. Now, the advantages of natural regeneration are low cost, less requirement of heavy machinery and labor. It gives you an aesthetically pleasing natural forest look. There is preservation of locally adapted populations, good adaptation to microsites and preservation of genetic variability. The disadvantages: the seed crop must be available, dry soil conditions may result in heavy mortality, insect and seed feeders may consume most of the seeds, competition from other vegetation, little control over spacing and stand density, little control over genetic improvement, and the site may take longer to regenerate. Next, we have assisted natural regeneration. It is a method for enhancing the establishment of a secondary forest from degraded grassland and shrub vegetation by protecting and nurturing the mother trees and their wildlings inherently present in the area. So, what you are doing is that you are protecting and nurturing not only the mother trees, but also their wildlings. Now, what kind of assistance do you give? It is done through removing or reducing barriers to natural regeneration such as soil degradation, competition with weed species, recurring disturbances like fire, grazing and harvesting, and unsuitable microclimate, and at times enrichment planting may also be done. Now, the steps: mark the woody regeneration, liberate the woody regeneration by removing nearby growth in a ring weeding fashion. So, in the case of any young plants, you are removing all the weeds in a ring fashion around the plant. Next, you have suppression of vegetation by pressing the grasses using a board. Protection from disturbance and maintenance and enrichment planting are done as and when necessary. Advantages: it is simple, it is inexpensive, it is effective, there is an accelerated growth in comparison to natural regeneration, it is less costly than artificial regeneration. So, essentially this is having the benefits of both the natural regeneration and the artificial regeneration. It is simple and yet it is cost effective. It provides job opportunities to communities, which is very important for, say, social forestry. The disadvantages are that you have less control than natural regeneration than artificial regeneration. There is a need for skilled labor, there is a need for detailed training of workforce, and the timing often clashes with agricultural timing, which reduces community participation. But if you do not have adequate amount of community participation for, say, ring weeding or for the use of the board to suppress the grass, then the ANR process may come up in a jeopardy. Next, we have artificial regeneration, the renewal of forest crop by sowing, planting or other artificial methods. Objectives are either to reforest, in which case you are restocking a cleared woodland, or afforestation, in which case you are establishing a forest on an area from which forest vegetation has long been absent. So, you are essentially creating a new forest. Steps: so it can be done through direct seeding or through planting. In the case of direct seeding, you do harvesting and preparation of the site, obtain the seeds, treat the seeds, say by adding water to it or by adding fungicide to it. Then you do sowing. Sowing can be done by broadcasting, in which case you are just spreading the seeds by throwing them, or you can do dibbling by using a dibbling stick or a dibbling rod, or you can go for a line sowing, strip sowing, patch sowing, and so on. If you are doing artificial regeneration through planting, first of all you do a species and stock selection, and your stock can be in the form of bare root seedlings, containerized seedlings, or vegetative propagation. Then you do harvesting and preparing the site, choose a planting, and once you have choose a spacing, and with that spacing you dig pits, and then on those pits you do the planting operation. Advantages: you have a very good control over plant density, there is a high flexibility including to change the species or variety, low management intensity, option to introduce improved seed or planting material, quicker results, better yield, and it creates even aged forests. The disadvantages are that it is cost intensive, labor intensive, less adapted to microsites, and there is more disturbance to soil and the area. Then we looked at silvicultural systems. Silviculture is the art and science of cultivating forest crops. System is a set of things that is working together as parts of a mechanism or an interconnecting network. So, silvicultural system is a planned program of treatments during the whole life of a forest designed to achieve specific stand structural objectives. So, you are integrating harvesting, regeneration, and tending methods. So, what is a stand? A forest stand is a contiguous community of trees that is sufficiently uniform in composition, structure, age, and size, class distribution, spatial arrangement, site quality, condition, or location to distinguish it from adjacent communities. It may be even aged, in which case the trees growing within the stand have only small differences in their ages, usually less than 20% of the intended rotation. Uneven age, they have large differences, and two age, in which case you have two distinctly different ages of the trees. Then we defined rotation as the planned number of years between the formation and the final felling of a crop, or the average age at which a tree is considered mature for felling. Now, silvicultural system is used to achieve specific stand structural objectives, which can be age class structure, site occupancy, preferred species mixture, spatial distribution of trees in a clumpy fashion or in a uniform fashion, and creation and maintenance of desired special structural attributes such as snag trees for wildlife. Now, in the case of a silvicultural system, this is the sequence. You begin with harvesting of the site. So, you are cutting the trees, removing the timber, then you regenerate the site so that the young generation comes up, and then you do a tending of the stand so that it is able to form the new forest once again. Now, harvesting is the aggregation of operations including pre-harvest planning and post-harvest assessment related to the felling of trees and the extraction of their stems and other usable parts from the forest for subsequent processing into industrial products, also called timber harvesting. So, harvesting is all operations from pre-harvest planning to post harvest assessment. Next, you have regeneration, the act of renewing tree cover by establishing young trees naturally or artificially, generally promptly after the previous stand or forest has been removed. Next, we have tending, an operation carried out for the benefit of a forest crop at any stage of its life on the crop itself or on the competing vegetation. So, this is a very important definition. It is done for the benefit of the forest crop at any stage of its life and on the crop itself or on the competing vegetation. It includes things like cleaning, thinning, pruning, improvement felling, weeding, climber cutting, girdling and so on. Now, what are the objectives of a silvicultural system? First is to meet the goals and objectives of a working plan, producing predictable harvest over time, balancing biological, economic and ecological concerns, providing for regeneration, efficiently and effectively utilizing growing space and site productivity, and sustaining non-market values in ecosystem services. Then we looked at a classification of silvicultural systems, and we require different silvicultural systems because there are differences in stand characteristics, management objectives and the availability of technology and manpower. Then we looked at clear felling system, in which case you have a concentration of felling and regeneration operations on a part of the area and the whole of the old crop is cleared in a single felling. A harvesting system in which all merchantable trees within a specified physical area of land are felled and no significant tree cover remains. Characteristics, successive areas are clear felled. It can be done in a departmental, the regeneration is generally artificial, generally done as departmental regeneration or tongia, in which case we take the help of villagers. And also sometimes natural regeneration is used in the form of seeds stored in the area, making use of advanced growth or vegetative or coppicing methods. The characteristics, all the vegetation gets removed, all the growing space becomes available for the new plants. The characteristic of the new crop is an even aged. And the deviations, you can prevent unnecessary sacrifice by leaving a few promising groups of trees, regeneration of mature trees as a nurse crop, girdling of unmarketable trees and designing of the pattern of felling depending on the local conditions. Now, types include standard or uniform clear cut, patch clear cut, strip clear cut, clear cutting with reserves and slash and burn. Now, there is the formation of coops. Now, coop is if you have a rotation of n years and you need to form equiproductive areas, so that in every year roughly equal area gets filled, then you divide the area into n sections and 1 by nth of the area gets worked each year, and these are the coops. Suitability, it is good for light demanding species. Regeneration, it depends on the regeneration ability of the species. Whether or not you will use clear felling will depend on soil cover and so on. Advantages, it mimics the natural processes of fire and large scale insect attacks, supports the pioneer species and may be used to raise certain species that cannot compete in mature forests. It is simple, easy and efficient operations, concentrated work, better financial returns, suitable for light demanding species and so on. In the case of disadvantages, you cannot use it for shade bearer species, and at times if you cannot ensure the regeneration, then you will have the denudation of the forest cover, and it cannot be used in frost prone areas, in areas that are more prone to soil erosion and so on. Next, we looked at shelter wood system. So, in the case of shelter wood system, the concentration of felling and regeneration operations is on part of the forest area. The clearing is done in terms of successive regeneration fellings, and the canopy opening can be done evenly over the compartment in the case of uniform shelter wood, in the scattered gaps in the group shelter wood, and in an irregular and gradual manner in the case of an irregular shelter wood. Now, shelter wood system is a method of securing natural tree reproduction under the shelter of old trees, which are removed by successive cuttings to admit to the seedlings a gradually increasing amount of light. Now, the need is that some species are shade tolerant, but they cannot tolerate harsh sunlight during the early growth stages. Some species require greater moisture. You may need to maintain cover and habitat for wildlife, or there may be a need to grow a forest with good natural aesthetics. So, you have 4 stages. You begin with a preparatory felling, followed by seeding felling, followed by secondary felling, followed by the final felling. Now, preparatory felling is felling made with the objective of creating favorable conditions for seed production, generally done towards the end of rotation when you are now ready to harvest the timber. And in preparative felling, you remove less valuable species, trees not putting increment, and dead, dying and diseased trees. In the case of seeding felling, it is made with the object of opening the canopy to secure regeneration from the seeds of trees. So, the seeds have already fallen down or are in the stage of coming down, and you are now giving it a bit more light so that it can get regenerated. So, you retain good seed trees, remove the overwood. In the case of secondary felling, it is a felling made with the object of opening the canopy to remove shelter and allow more light for the regenerated crop. And in the case of final felling, you remove all the last shelter trees and the seed trees. Advantages: it enables natural regeneration to renew the forest, suits the species that are shade tolerant and moisture loving during the early stages. It protects the seedlings from frost, drought, cold during early stages, and with further cuttings, more and more canopy is open and more light is made available to the growing of plants. Thus, the plants develop uninhibited. Then it maintains cover and habitat for wildlife, creates a forest with good natural aesthetics, and creates an even aged stand which is useful for concentrated working. Soil gets protected and the best trees get an opportunity for an enhanced increment when opened out in the regeneration felling. Disadvantages: you require more labor, there is more amount of skill that needs to be imparted, there is lesser concentration of working, residual damage, young crop takes more time to establish, and the rate of cutting and regeneration is more difficult to control. Next, we looked at the other variations. So, you have uniform, group, strip, irregular, natural shelter wood, and combinations of these different shelter wood systems. We looked at periodic block, which is the part of a forest set aside to be regenerated or otherwise treated during a specific period. Regeneration period is period required to regenerate the whole of a periodic block, and the number of periodic blocks is given by rotation age divided by the regeneration period. Now, in the case of shelter wood system, we typically have 4 periodic blocks. The PB1 is the one where you are going to do your felling operations, followed by PB2, 3, 4 and so on. Now, the cycle of periodic blocks, if you look at PB1, it is containing trees from 90 to 120 years. Once you have harvested these trees, then it becomes PB4 from 0 to 30 years, then it becomes PB3 from 30 to 60 years, then it becomes PB2, and it again becomes PB1. Now, regeneration is dependent on the frequency of seed years, light requirement, soil condition, presence of competition, invasives, grazing and browsing, abiotic pressure and forest fires. Next, we looked at group system, which is a concept that was given by Carl Gehr. In this case, the regeneration felling is done in groups, either due to the presence of advanced growth or to induce regeneration, and then the area is enlarged centrifugally. So, in this case, you identify the advanced growth, do the preparatory felling, then in the next stage you do seeding felling in these areas, and you are also increasing the areas centrifugally where you will be doing the preparatory felling, and slowly and steadily these areas will increase. Advantages: the use of advanced growth reduces the regeneration period, provides adequate protection, less wind damage. The disadvantages: it is difficult to locate advanced growth, difficult to mark the trees. When the gaps become large, wind damage may occur, and regeneration may be damaged while logging, and it is complicated. Next, we looked at selection system. In the case of selection system, concentration of felling and regeneration operations are continuous over the whole area. So, felling and regeneration are continuous over the whole area every year in an ideal selection system. Felling and regeneration are done without interruption over infinite number of years or a very long period. It produces uneven aged crop in every portion of the forest. Regularity is expected. You do not have a rotation age, but you have a selection DBH or selection diameter at breast height, and because there are no interruptions in the main canopy, so greater than 1 tree length, so the stand structure and dynamics are highly diverse at small spatial scales. Applications: we generally use it for steep, broken, rugged topography areas, catchment areas, remote areas, areas with irregular seeding, areas requiring natural aesthetics and close to nature forestry. Pattern of felling: you can have all the areas every year in an ideal system, or you could go for a periodic selection system in which you work on one block for n years. Felling cycle is the time gap between successive main fellings on the same area, and exploitable size is determined taking into account the regeneration of the forest. In the case of a selection system, you get an inverse J type of a number diameter curve. Felling rules: you remove dead, dying, diseased trees, undesirable trees, excess immature trees to bring your system close to the inverse J curve, and mature trees above the exploitable diameter. The advantages are more natural forest, continuous canopy, a multi-tier system, so more growing stock is available, greater increment, soil is not exposed, it is resistant to pest, adverse climate, weeds and grasses, and abundance of seed bearers gives you a good natural regeneration. Disadvantages: again, you require more skilled workforce, more cost of logging, genetically superior trees may get preferentially removed, and there is a greater risk of grazing and damage to the young crop. Next, we looked at irregular shelter wood system, in which case an irregular stand is a stand where the age classes do not occupy approximately equal areas, and if you have such a forest and if you want to maintain the irregular characteristic, then you can go for an irregular shelter wood system. The simplest of which is the Indian irregular shelter wood system, in which case you follow the prescriptions of a uniform shelter wood system in a normal terrain and the prescriptions of a selection system in a difficult terrain. So, you are maintaining your trees according to both shelter wood system and the selection system, and so the forest is retained as an irregular stand. Now, the characteristics: it is a compromise between shelter wood system and selection system, with regeneration fellings on the pattern of uniform shelter wood system or group shelter wood system, but with very long regeneration periods on the pattern of selection system, with the main objective of light increment resulting in irregular uneven aged forest. Advantages: there is adherence to natural system, more flexibility, more increment, varied forest with better site utilization, but the disadvantages are that there is very intensive felling. Scattered fellings in a large area leads to a costly process. There is a regular damage to the young crop, requires skilled labor force, favors the shade bearers, young crop remains under shade for a long time, and the trees may get branchy. Now, with a choice of all these different silvicultural systems, you can choose which one you want to use depending on which crop you are using, whether it is shade tolerant or light dependent, what is the kind of site that you are working with, and your silvicultural objectives. So, that is all for today. Thank you for your attention. Jai Hind.